On January 16th, I got my first dose of the COVID vaccine.
Okay, take a still picture with the news, okay? All right.
Welcome Dr. Carissa Culbreath, a clinical microbiologist, to explain to us how the vaccine
It's
works.
so wonderful to be back with the St. Paul family. You guys are family to me, so I hope I feel like family to you, and I can't wait for the time when we can all come back together and I can come and visit. But the vaccine it's an mRNA vaccine. And so what that means is that what is the component of the vaccine is a portion of the genetic material, the mRNA, that the virus uses. And so, what the scientists have done who developed the vaccine is they've taken a little piece of this genetic material, and that's what's in the vaccine. And so, when that's injected into your body begins to use that RNA to make proteins. And that spike protein is how the virus could get into your cell if it was attached to a whole virus. But what's happening in the vaccine is that we just have a little piece of the edge of the spike protein, and our bodies make the spike protein. And then when that spike protein is in our bodies, that little piece of the protein, now our immune response gets activated. And the different cells that are part of our immune response, T cells and B cells, they go to work. B cells are the ones that make antibodies. So they're the cells in our body that anytime any infection, any pathogen comes into our body, they make antibody. What the T cells do is they have two jobs. They either help the B cells make antibody, or they help to destroy any cells that are infected with a pathogen or a virus. And so the once you get your vaccine and the first dose starts that response, the second dose boosts that response and just reminds the B cells and the T cells, hey, remember this little piece of protein? This piece of protein's a bad guy. You remember this? And it reminds that those cells again, it's time to make a response to this. And once we get that second dose, B cells are activated. They remember, oh, we know how to make antibody, and we know to make antibody towards this piece of the protein. And the T cells help the B cells make antibody, and they are reminded that if there's a cell that's actually infected with this virus, that they need to destroy the cells. And so now that just locks in the immune response so that anytime in the future that we begin to see coronavirus in our bodies, our immune response becomes activated.
Talk about the difference in this technology.
So this technology is really different from having a live virus type of vaccine. With what happened with the mRNA vaccines that we see now, certainly with the Pfizer and the Moderna vaccine, is that they're able to accomplish the production of the mRNA fragment in the laboratory in a way that's much easier than trying to grow up the live virus. And so they're able to base their knowledge of how we produce the vaccine on the genetics of the virus rather than growing up large quantities of virus. One of the things this is really, really good for is, we're hearing information about these new strains that are emerging in different parts of the world. Should new strains emerge, then we are able to produce an mRNA vaccine potentially that would be able to cover a strain if it became necessary. And so we're able to move much quicker and respond with booster shots and future vaccination efforts should it becomes necessary by using this mRNA-based vaccine technology rather than a live virus that we have to have the virus and then grow it up and then distribute it out to the population.
Part of what's so exciting to me about this is the way that it, to me, symbolizes the beautiful marriage of the natural world and scientific knowledge. Um, that what we're really doing is finding ways to stimulate our bodies to heal themselves.
As I was even thinking about it, I put that Facebook post up. I started thinking about the Psalm 139, and it's that like self-esteem scripture, right? But also, thinking about how God has formed my inward parts, right? Every cell in my body, right? Every receptor, every ribosome, right? It's the ribosomes that the mRNA get put into, and the ribosomes are the ones that produce the protein, and they pick up the amino acids based on the code that's in the mRNA. And it's like, it's those, like, into those inward parts, we see how, God uses our entire system to be able to bring about our healing. People often see, is there conflict between faith and science? And all I see is that my faith and science, they just reveal one another to me every time, right? Every time I look deeper in science, I become more in awe of the God that created these inward parts and these cells. And every time I think about God and how God is moving in my life, it just enriches my science, and it enriches my quest for, I want to know more about this wonderful creation that we are. Our immune systems are active at all times. And there's so many times I think about what, the elders would say when during testimony service, I thank you for keeping me from danger seen and unseen.
Right.
And every day our bodies encounter pathogens and viruses and bacteria. And every day our immune systems are fighting and keeping us healthy and keeping us well. Right now we know about coronavirus, but all of the other viruses and bacteria that tried to come, and our immune systems responded in times that we didn't even know that we needed to be protected. It showed up every time.
I continue discussing COVID mutations and herd immunity with Dr. Culbreath next week.